Hello, everyone. My name is Rob Higurita, and I'm a Principal Technical Account Manager at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS Support. Joining me today is Anish and Swapnil from AWS Support. Can you give us a quick introduction, Anish, and then Swapnil?
Yeah, sure, Rob. My name is Anish. I'm a technical account manager based in Dublin, Ireland, and I work with enterprise customers to help them build a cost-effective, highly available, and low latency solutions with AWS big data services such as Glue, EMR, DynamoDB, Kinesis, Spark, and Athena. And I'm really excited to be part of this show today. Over to you, Swapnil.
Thank you, Anish. Hello, everyone. Myself, Swapnil. I'm a cloud support engineer and a Glue subject matter expert based in Dublin, Ireland. I work with customer base globally, helping them and supporting them with various AWS big data services, including Glue. I'm really happy to be here. Thank you.
Awesome. Thank you both for the introduction. So today we will be introducing the audience to AWS Glue. We'll be specifically focused on performance improvements by leveraging JDBC Parallel Reads from AWS Glue and some further best practices for optimizing those JDBC reads. But before we do go into the details of today's episode, a quick note to the attendees online. Please feel free to use the chat window on the right-hand side of your screen to ask your questions throughout today's episode and really pick, Swapnil and Anish's brains today. So we look forward to hearing from you. Anish, can you go ahead and walk us through what we're going to be talking about today?
Yeah, sure, Rob. So in today's section, we have broken down the presentation into two sections. In the first section, I will be going through what is AWS Glue as a service. We'll have a quick look at the overall flow of Glue in terms of ETL jobs. We'll be then looking at AWS Glue components, and then we'll have a look how Glue is built over Spark core, and be discussing about Glue DynamicFrame and Spark DataFrames. In the next section, Swapnil will be talking about integration with JDBC database sources and the benefits of parallel reads. He'll be then talking about how to calculate the maximum parallelism. And in the end, we'll be going through a demonstration with the sample ETL jobs and to figure out how we can optimize the ETL job runs. So let's move on to the next section. So what is AWS Glue? Now, AWS Glue is a cloud-optimized extract, transform, and load service, ETL for short. Basically allows you to organize, locate, move, and transform all your data across your business so you can put them to use. Now, Glue provides crawlers with automatic schema inference for your semi-structured and structured datasets, meaning crawlers automatically can discover all your datasets, discover your file types, extract the schema, and store all this information in a centralized metadata catalog for later querying and analysis. Glue also automatically generates the scripts that you need to extract, transform, and load your data from source to target, so you don't have to start from scratch. And the best part is Glue is serverless. That is, you simply point Glue to all your ETL jobs and hit run. You don't need to provision, configure, or spin up servers, and certainly you don't need to manage their life cycle. Now let's have a look. How does the overall flow looks like? Now in this diagram, you can see on the left-hand side, there are the data sources ranging from Amazon relational database, Glue catalog, your in-house JDBC databases, Amazon S3, streaming data, and you can connect them via using Glue connector or Glue crawlers. Once the connection is established, you can basically catalog into the Glue catalog your structured and semi-structured data. And once the catalog has been done, you can basically transform all your data as per your business needs via Glue Studio, Dev Endpoints, and AWS Glue Data Brew, where you don't even have to write a single piece of code. And once the transformation is done, you can then basically move the data to the data location wherever the data target is. And it could be any of the NoSQL databases, data warehouses, or it could be your in-house JDBC databases as well. So let's have a look at the major Glue components. Now, the first component here is the data catalog, which is basically the centralized metadata store for all your analytics data in AWS. Now, with data catalogs, you have crawlers, which, as I explained, can extract the structure, and load all of the metadata into the catalog. Now, catalog is Hive Metastore compatible. So other analytics services like EMR, Redshift, and Athena can integrate with the catalog and perform analytics. Now, the another major component for Glue is its serverless job execution system. At the core of job execution system is an open platform, Apache Spark, that runs all your jobs. You just submit your ETL jobs written in Python or Scala, and we provision all the infrastructure that is necessary to run these jobs. And all you do is pay for the time that job ran. Now, if you don't have coding background, that's no problem. Glue provides you tools based on data present in your catalog that will automatically generate that you need for transformation from one source to another. Now, third and the last component is the Glue orchestration system. It basically allows you to stitch together multiple jobs to accomplish a larger task. And it can be done in a linear fashion or a directed acyclic graph for jobs to put together. And the best part is you can monitor the status and check for failures and can also integrate with other AWS services. But let's have a look how a Glue ETL environment looks like. On the top left-hand corner, you can see the different flavors of JDBC data sources like Oracle, MySQL, Postgres. And on the bottom, you can see the AWS native data sources like RDS, DynamoDB. And you can basically perform ETL on any of these data sources and can move the transformed data to any of the data targets, which can be, again, your in-house JDBC data sources or the native AWS services. And Swapnil in the later section will be diving deep more into this section. Now, in order to understand what ETL script is doing, it is very important to actually understand how the system is built. So Glue is actually built on top of Apache Spark core. Now, at the bottom, you can see you get the RDDs, which is the resilient distributed data sets. These are basically data structures that allow you to put data in them and then run operations over them in a fault-tolerant way. Now, Apache Spark itself has a built-in additional data source on top of it's called DataFrames. And DataFrames are optimized for doing SQL-like analytics. Now, in Glue, we have a parallel set of libraries or data structures called DynamicFrame that are basically optimized for ETL and then bunch of transformations on top of DynamicFrame that make data cleaning easy. Now, as explained in previous slide, the data frames are basic core data structures for Spark. They're like structured tables with data frames where we need schema upfront and each row has the same structure. Now, when it comes to ETL jobs, you're looking at unclean, incomplete, semi-structured data, for example, logs in Avro or JSON format. So what dynamic frames do is they actually store the structure of each record with record itself. So every record can be different from the previous. Now, there's no need to have schema upfront, no need to pass over the data to complete the schema again. You can just start running operations over it, and that's why it's very useful for ETL. Now, it's very important to understand that data frames and dynamic frames are not competing with each other. They go hand in hand complementary. Now, you can turn dynamic frame to data frame and vice versa, and can make use of them as per your use case. Now, before I move on to the next section, Rob, do we have any questions from the audience?
Hey, thanks, Ish. Yeah, we don't have any questions from the audience right now. So attendees, please make sure to post your questions into the chat. But I do have a question. You mentioned that Glue is built on Apache Spark. How does Spark data frames differ from the AWS Glue DynamicFrame?
Yeah, sure. So as I mentioned, they both have their own use cases. Dynamic frame is more for uncleaned data or semi-structured data. But when you have use case where your data is structured, you can always go for data frame. Now, Glue supports both dynamic frame and data frame, and you can convert them as per your use case.
Oh, okay. Thanks. Appreciate that. So I'll let you carry on through the rest of the presentation. Thank you.
Perfect. So moving on to the next section, I'll pass over to Swapnil, who will be talking more about the integration with JDBC data sources.
Sure.
Over to you, Swapnil.
Anish. Thank you. So in the coming slides, we'll be talking about how Glue interacts with JDBC data source. And more importantly, we'll be focusing on why parallel reads are better in terms of JDBC reads as compared to default read. And the topic will be focused on Spark and also Glue, because Glue, again, as Anish said, is built on top of Apache Spark. So before I start off, I would like to add a customer use case where they were using AWS Glue to read their data from JDBC and write out to Amazon S3. The use case involved to carry out business analytics from the data written out to Amazon S3. However, since the default read are single threaded, which means only one executor will be used to read the entire data source, the job was taking longer and eventually would fail with out of memory. Customer did retry the job multiple times, but it always failed. And due to the nature of the job and the time it took, they were nearing to the deadline. And unfortunately, the issue got escalated on their end. I was working with this particular customer and I reviewed the ETL code and saw that they were using default JDBC option. My main task was to get them out of the production pain. So once I reviewed the code, I detailed them about the parallel read parameters in Glue and also in Spark, and help them with the code and how parameters they can, what parameters they need to add. And with the parallel read operation, customer had the job running much faster. Unfortunately, they were able to reach their deadline and carry out the business analytics. So as you can see, the default JDBC reads, the job will make a single connection to the JDBC data store. And that particular connection will do a select star query to read the entire table. So generally for a smaller table, default read won't make any problem. But in today's big data world, where we have a million and billions of records in a JDBC data store, a single query to read the entire table will definitely cause the job to run out of memory. So we can see in parallel JDBC read instead, there are multiple connections made to the JDBC data store, hence we name it parallel. And the select star query are run in parallel. Basically, each of the query will only read a part of the table instead of one query reading the entire table. So benefits of JDBC parallel reads will definitely give us a faster job runtime. We'll be talking about this in the demo. Uh, Obviously, the job runtime comes down, and in Glue, you only pay for how long the job runs. So definitely, this will reduce the cost in parallel JDBC read. And the memory and the CPU burden is less not only on the Glue executors, but also on the JDBC source. On the Glue executor, parallel executors are used to read the part of the table, to read the records in the table. So there is no one executor reading the entire table. And also on the database side, we don't have any single select star query to read the entire table. And we have smaller queries to read the data from the tables. That's why we see a reduced CPU and memory load on the database. So let's continue about integration with JDBC data in the next slide. So just a continuation of what Anish said. So let's focus on JDBC with respect to AWS Glue here. So for data sources in AWS Glue, we can have your JDBC databases. So any database that can be reachable over a JDBC protocol can be used as the source for AWS Glue. So your JDBC database can be an on-premise database or a database based on other cloud offering. Amazon RDS is a well-known JDBC database engine, so that can be used as a source as well. Or else a customer might have a Glue catalog table which is based on JDBC. So these can be used as a source for my Glue job. Once I'm done with my source and I carry out the transformation, we can focus on the targets. So targets, similarly, I can write out to on-premise and other cloud-based JDBC databases. I can also write out to my Amazon RDS and Glue Data Catalog. But now, moreover, I can also write out to Amazon S3, Amazon Redshift, and also to my DynamoDB table. So this is more of interaction we have seen with customers where what are the typical data sources and data targets they use. So let's talk about this in detail. So let's move to the next slide. So before we jump in more, we need to understand how we can dictate or what parameters dictate upon the maximum parallelism. So The DPU is the basic unit, and to put things in short here, DPU, the number of DPUs that is used in the job will account for the billing. So Glue offers three different worker types: standard, G1X, and G2X. As we can see in the chart, the Spark driver memory and the executor memory changes across the worker type, where G2X provides the maximum of the memory. We recommend customers using G2X worker type for machine learning operation, and we recommend them using G1X for memory intensive jobs. So once the customer knows the worker type they are using, the, the, the Spark executor cores provided by each of the worker type will be defined. Now, once we know the Spark executor core, we'll talk about how many executor my job is having. So to continue on this, let's move on to the next slide. So the number of maximum Spark executors will again depend on my worker type and also depend on the Glue version I'm using. So once I know these two values, the number of Spark executor and my Spark executor cores, the multiplication of these two will give me the value of maximum parallel task. So this is the default formula. And what we mean by this is these many number of parallel tasks my job can do as opposed to a single thread operation. So let's dive in to more of the parallel parameters that can be used for JDBC read. So let me start with JDBC read parallel reads in AWS Glue DynamicFrame. So in Glue DynamicFrame, we have three parameters that will enable us to do a parallel read operation. They are hash expression, hash field, and hash partition. Customer can either use hash expression or hash field, and you do not need to specify both of these parameters. So let me start explaining about hash expression. So for hash expression, you need to simply specify a column value in my JDBC data source. That particular column should return a whole number in my SQL-like expression. So that is the only requirement for that particular column. A simple expression will be a name of any numeric column, like say an ID column, which is my primary key incremental value, something like that. That is the ideal candidate to specify as a hash expression. The second option is in case if a customer do not have any numeric column as such, customer can use hash field option. A good thing about hash field is a column data type can be of any data type basically. So any column, be it of any data type, can be specified as a hash field here. And once customer decide whether to specify hash expression or hash field, then the parameter comes in is hash partition. So as the name suggests, hash partition will be basically the number of connections that the Glue job will make to the JDBC data store. For example, if hash partition is specified as 10, that means my job will make 10 connections to the database, and each of the connection will read basically a part of the table instead of a single query to read the entire table. In case if hash partition is not specified, the default value is 7, which means that again, 7 connections being made to the database, firing 7 queries to read the table in parallel. So let's talk about hash expression in more detail. In the next slide, I have a sample code over here. Okay, so before we dive into this code, Rob, do we have any questions?
Hi, yes, we do have a couple questions that have come in since we're kind of covering these items here. So our first question comes in from Ramon 357. Is the schema registry in Glue open source?
I'm not sure about it, to be honest. The schema registry part is actually for more of you're focusing on the streaming part. So it's still in preview as such. So it's not open source as such, but it's more of I won't be very much sure about this particular answer.
Okay, great, thanks. And then one other question that just came in from Tame242, which I believe you're kind of covering a little bit or going through. Can I control the number of DPOs I want to use?
Yeah, of course you can. So basically, in one of the slides we discussed, when we create a job, you need to specify the worker and the number of workers you're using. So let's say, for the sake of example, I'm using a G1X worker type. So each worker type in G1X is equal to one worker is equal to 1 DPU. So if I specify my job with say 10 G1X worker, that will map to 10 DPUs, and the job will be charged according to the DPU rate. So obviously, customer has a control over the DPU they want. Say for a job with less memory and CPU requirement, a job with 5 to 10 DPU should work fine. But for a job with memory intensive operations, the DPU number will go up. So it more of depends on the vertical scaling of the job.
Great. Thanks for the answers, Tom. I'll let you continue on here about your hash expressions and such. Appreciate it.
Thank you, Rob. So let's continue to hash expressions now. So in hash expressions, we have sample code here. In sample code, I'm specifying my JDBC URL, my user, password, and the table name. So this is how the default reads happen. But more importantly, we can see I'm specifying my hash expression as ID and my hash partition as 10. ID is my column in my JDBC data store. It is a numerical column which auto-incremental value. And hash partition I'm specifying as 10, meaning that I want my job to make 10 connection to data store and read in parallel. So with this particular code, if you look at the sample queries that are fired on the data store, job will use a modulus operator and such that it returns 10 different values from 0 to 9. 10 different values again because hash partitions are 10. So we see that 110, each query will ideally read 1/10 of the table instead of a single select star query reading the entire table. So this is how the sample queries are fired to read in parallel when hash expression is used in AWS Glue DynamicFrame. Let's talk about hash field in the next slide. So the sample code again is pretty much same here. The only parameter which is obviously has changed is hash field. So instead of hash expression, I'm specifying hash field in my code, and I'm using the title column. So a title, as said, any of the column data type can be used as a hash field. So in my example, I'm using a title column, and hash field, as the name suggests, will calculate the MD5 hash of the records in my title column. And it will calculate such that it creates a 10 unique set of rows, and again 10 because of hash partition being 10. So if we review the sample queries that are fired, again a modulus operator is used for each of the MD5 hash value calculated, returning 10 different unique values ranging from 0 to 9. So this is how we can see that there are multiple queries that get fired on the data store to read in parallel, as opposed to a single query to read in the default JDBC operation. So this is how we do the JDBC parallel read operation in AWS Glue DynamicFrame. Let's talk about parallel JDBC read in Apache Spark DataFrame. So the parameters here obviously are different. The partition column is where you will specify the column to dictate the partition. So this is similar to what we saw hash expression and hash field was. So in Spark DataFrame, we'll specify the partition column. The limitation on Spark DataFrame is that the partition column has to be a numeric date or a timestamp column. So once we have identified that column, that can be specified as a partition column. Then customer need to specify the lower bound and the upper bound value. Keep in mind these values are only strictly to calculate the size of the partition, and these do not dictate upon the specific SQL-like query to read the part of the table. So once I know the lower values and the upper value of my partition column, this will dictate upon size of the partition. We'll touch upon the sample values of lower bound and upper bound. It will be interesting to know these in the next slide. And then the last parameter will be, just to go back on the previous slide, Anish, sorry. Yeah, so the last parameter we have is num partitions. As the name says, these are the number of partitions that can be used for parallelism. And this is similar to what we saw hash partition in AWS Glue DynamicFrame. So num partition, again, it determines the number of connections that will be made to the JDBC. So now let's move on to the next slide. So I'm creating a Spark DataFrame DF. I'm using Spark read format and specifying the default options, the required options, which are my JDBC URL, my username, password, and table name. So this is how the default read happens in Spark DataFrame. But now we are focusing on parallel reads. So we'll specify the partition column, which is my ID column here. I'll specify the lower bound and upper bound value. So my ID column has the lower value of 1 and an upper value of 1000. So that is what I specify here respectively. And then my number of partitions, num partition as 10. So my upper bound value is 1000 and my number of partitions are 10. So 1000 divided by 10 will give me 100. So roughly speaking, each of the query will only read 100 records. And we have 10 queries because of 10 num partitions being specified. So if you reviewed the sample queries that is fired on the JDBC data store, the ID value is where clause is used against the ID values. So first query will read only the ID values ranging from 0 to 100, from 100 to 200, and so on until 900 to 1000. So this is how the parallel read operation will happen in Apache Spark DataFrame. Moving on to the next slide. Now that we have discussed on how parallel read enhances the job performance and what are the parameters and how the parallel read operation takes place, it is important to understand that we do not overwhelm the JDBC data store. By that, I mean that a customer at the JDBC data store might have a configuration which can allow only a maximum of, say, 10 connections. And if my parallel read and specifying my number of partition or hash partition as 100, this will definitely cause a problem in my data store. So I should also know about the maximum connection my database supports. Since there are queries fired, be it on a parallel operation or a default operation, I should also check the connection timeout value because any of the query which may take longer can also face timeout values. So it's important to review the timeout values. And more importantly, I should also be aware of my CPU and memory performance of the JDBC data store because any of the query might have ununiform data and that can run longer and eventually cause out of memory. So once I review these parameters, I should go with parallel read operation. And in most of the cases, we do see that there is no problem as such, but it's always better to review these parameters on the JDBC data store beforehand. So moving on to the next slide. So I have a small demo where I will be using Glue DynamicFrame operations for default read and parallel reads. But before I do that, Rob, do we have any questions?
I think so. We don't currently have any questions from the audience. So audience members, please make sure to post your questions here. And we can maybe answer some of those as we get through the demo here. So thank you. I'll let you go through your demo.
Okay, thank you, Rob. So this is my demo where I'm using Apache Glue, I'm using AWS Glue Studio to create a job. This particular job basically is I have a MySQL RDS and that will be used as a source. And I'll compare the default read and I'll also compare how the parallel reads execution type and the code works. So I'll go with the default option in Glue Studio and do a create job. Since I need to specify my custom JDBC URL, I'll go to the script option and I will do an edit script. Firstly, here I'll import a couple of libraries. So I'll import Boto3 and the JSON library. We are using Amazon. So Boto3 is the Amazon Python library, and we are using it to call out AWS Secrets Manager. So let me remove this part first. So I'm creating a Boto3 client here. And with AWS Secrets Manager, I'm pulling out the details like database username, URL, password, and the table name. So by this, I need not to hard code my database credentials in my code. Then I'm creating a data source 0 named Glue DynamicFrame with MySQL as my connection type. And then I pull out the username, password, URL, and the table name. So this is the default option on how I can read from JDBC data store. And I'll call a Spark action.count to make sure my job runs. So as we know, for a Spark job to run, we need to call upon an action. So .count is my action here. And now before we run this job, I need to fill in some job details here. So I will name this job now. Let me name it as test. I'll specify my IAM role to be used here. I will use Glue 3.0, the latest available version, and I'll stick to the default G1X worker type and the number of worker 10 provided to us. I will make sure that I have Spark UI enabled. We'll be reviewing Spark UI for each of the job run, and we'll also check up on the DAG on how it looks with the default and parallel read. And lastly, I will specify a Glue connection. This connection will make sure that my Glue job has access to the JDBC data store. And this looks fine now. So I'll save this job, and now I can run the job. So in the run status, I see the job is now running. So let me jump over once this is succeeded. Okay, so the run status is marked as succeeded now. And an important point to review here is the execution time, which is 18 minutes. So the default read JDBC read with my data store took 18 minutes in this case. And if I jump over to the other tab and review the Spark UI, so let me have a close look at this DAG, and we can see there are two stages, and the entire operation is single-threaded. So this proves again that a single query, a single executor is used to read the entire table, and that is how it took 18 minutes for the job to be completed. So in the script, let me add few parameters here. So in Glue DynamicFrame, we talked about hash field and hash partition parameter. So let me add that particular parameters while I create my DynamicFrame data source 0. So I'm using my hash field as ID column in my data store, and I'm specifying the hash partition as 36. 36 is from the worker type I'm using. So G1X will give me 4 executor cores, and I'm using 10 worker type, one of which is the master. So I'm left with 9 executors. So 9 executor each with 4 cores will give me 9 multiplied by 4, 36. And that's how I get hash partition at 36. So with couple of parameters added, hash field and hash partition. Let me save this job. And I will run this job. So the run status is running. So let me jump over when this is completed. So now the run status is marked as succeeded. And the interesting point here is the execution time is down to 9 minutes as compared to the default read where we saw the execution time was 18 minutes. So we can see that job is basically 50%. It took basically 50% less time to be completed. So if I jump over to Spark UI for this particular job, and let me review the DAG here. So here's something interesting in the DAG. I should see 36 connections. So if I scroll all the way to the right, so it ends on 36. That means my job has made basically 36 connections to the JDBC data store, doing some map operations because of the dot count I have called upon. And that's why I see the operation is faster, the job is faster. Now that we have played around with hash field, let me go back to my script. And instead of hash field parameter, I will use a hash expression parameter. I will stick to the ID column for this example as well. And of course, I'm not changing anything, so my hash partition will be 36. So let's jump over once this is completed. Okay, so the run status we can see now is marked as succeeded, and the execution time is 12 minutes, which is again faster than 18 minutes for the default JDBC read. And then we see with hash field, we saw 9 minutes as the execution time, and with hash expression, the execution time is down to 12 minutes. So from this, we can see the execution time differences. And if I go back to the Spark UI for the last job run, I see the DAG is pretty much similar, where my job is making 36 connections. So let me scroll down all the way to the right, ending with 36. So it says that there is a parallel operation as from the DAG. So if I go to, let me go back quickly to the first job run, which was a default JDBC read. And in the DAG, we can see that it was single threaded. We go to the second job run with hash field option. The DAG we see is 36 connections being made. And same to the last job run, the DAG is pretty much similar. So parallel connections being made, showing that parallel read operation is happening. And we can clearly see the execution time differs. So for tables with millions and billions of records in it, with more columns in it, the JDBC parallel operation excels well, and we can see a considerable difference in the job execution time. So that should be it from my end. Over to you, Rob.
Thanks, appreciate it. Looks like there's definitely some improvements that can be made with those JDBC parallel reads. So thanks for sharing that information today. Anything else that you'd want to share today for our audience before we go?
That's all from my end. Thanks, Rob. Thanks, Swapnil.
That should be it from my end as well.
Perfect, thank you. So everyone, today we looked at JDBC read performance improvements with AWS Glue and saw how those could definitely be increased in the performance-wise. If there are any questions that were not answered today, you can post your questions over on repost.aws and email us any feedback to awssupportsyou@amazon.com. We want to hear from you. Tell us what else you'd like to see on the show. Thank you for joining us at AWS Supports You, and hope you have a happy day and happy cloud computing.